argument that came out. Tell us that story, Stan.
Well, there was a big noise when the story came out, and there were unfortunate aspects of it that you sort of can't blame some of the people who reacted negatively. The announcement was made at a press conference in Utah, and normally scientific breakthroughs are made by publishing a paper and in a respected journal, and it's been peer-reviewed, and, people have had a chance to look at it and see, oh, that sounds okay. But by press release, wow. So they were, on the one hand, people were saying it's a real breakthrough. I should stress here, what's a breakthrough here is that nuclear fusion is the most important source of energy in all our lives. The sun is a fusion factory. And it also has a bad side. H-bombs are fusion devices. But in either case, you're talking about very high temperatures being produced. And so cold fusion without high temperatures, that doesn't make any sense. And the way this thing supposedly worked, you'd have palladium, a metal known to absorb loads of hydrogen. It's used as a catalyst in other places. Pretty expensive, too, more so than gold, generally speaking. Anyway, they had a cell connected with the source of power, battery, basically, and it had palladium, and in it was heavy water. That is, normal water is 2 hydrogens, H2O for oxygen. This was D2O. D stands for deuterium, which is heavy hydrogen. Normal hydrogen only has a proton on the inside and an electron on the outside. Heavy hydrogen has a proton and a neutron. So it's heavy, but it has the same chemical properties, chemical, not nuclear, because of having the electron on the outside. And so here you load this cell with this heavy water, and you turn on the current, and you get excessive heat. And the idea was there must be fusion going on with that heavy hydrogen being absorbed in the palladium walls. And so it went through a succession of people saying it's impossible, people saying, oh, we did it too, others saying, no. They got hounded out of the university finally, and the nasty, noisy negativists were certainly at them. And, don't bother me with the facts. I mean, no matter that new data was published that showed something was going on, it was a disaster for Pons and Fleischmann, basically. But, as I point out in the chapter, as time went on, there were some people with guts, courage to check things out. Maybe we need to increase the ratio of the heavy water to the palladium surface area kind of thing. Maybe change the temperature. Maybe change the current. Let's see what's going on here. And the number of successful experiments producing excess energy kept going up. And, we've got some big guys in the works on this thing, the Electric Power Research Institute, Toyota Corporation, the Navy. Obviously, all of these would, kind of like to have good new sources of power.
Yeah, we've all dreamed about having a Mr. Fusion on the back of our cars, yeah.
Well, Ford has one, doesn't it? A Ford Fusion. Sorry.
No, I find it fascinating, because it's so much cleaner than fission because tritium has a 12.5-year half-life. So even if you have a mistake,
well, tritium's the least of your problems with fission. There are many radioisotopes produced when uranium.
Yeah.
And so there's quite a backlog of radioactive material produced. Now, it's safe. It's inside the elements and all that. But when I was working on fission nuclear rockets, for example, you can only run them for so long because you need aftercooling. There's so much radioactivity produced in the rocket that you better have some of your hydrogen propellant ready to use once you shut it down because it's still grinding out energy from the radioactive material. So it sounds ideal. And look, there's a long step when you've got new physics, so to speak, and new technology. An idea isn't enough. Reducing it to practice is the difficult part.
Sure.
And so it takes money, it takes effort, And many people are unaware of how much money is spent developing new, different kind of systems. I mentioned in the book that when I was working on nuclear airplanes for General Electric way back in, 1958, GE was spending $100 million that year, employed 3,500 people, of whom 1,100 were engineers and scientists. In other words, it wasn't 6 professors and 20 grad students.
Yeah, that's a heck of a brain trust there.
Yeah, well, $100 million in 1958 was a lot of money. Now, some people think it's pocket change now. I don't. But then, 3,500 people is a good-sized program.
Yeah, back then you could just about buy a country for that amount of money.
You probably can still do that now if you know whose hands to put the money in. So what I'm saying is that people think you have a eureka moment, you have an idea, and, very shortly thereafter you're putting it into practice and selling it down at the store, and everybody's buying one, you're making a ton of money. Well, there's a long, slow path between the original discovery. Lasers were invented 50 years ago, for example. And it took quite a while before they started doing useful things.
Sure,
Checking
yeah.
out CDs, and stuff like that.
But that's not really the argument of the impossibilist, though. The impossibilist just says heavier than air flight can't be done. It's not how much engineering does it take to get there. I mean, you and I, we look forward to that. Give us a box of parts and a half-written manual, and we're excited. We're ready to go to work. Let's build the darn thing. But impossibilists will say that it just can't happen. It's not going to happen. You're not going to get any money to do it.
And that's why I used the story of Goddard. He wrote a paper in the Smithsonian Journal, and this is around 1920. And the New York Times got a hold of it. In the paper, he suggested the possibility of flight into space. It wasn't just rockets, in other words, in the atmosphere, like for 4th of July. It was flying into space. And the New York Times roasted him. He was a professor at Clark University in New England. He doesn't even know what your normal schoolboy knows, that you need something to react against, and in a vacuum it won't work. Now, that was totally wrong. But the New York Times, in its infinite wisdom, didn't correct it until 1969.
Oh, come on.
The Apollo Command Module was due to land on the moon. Then they said, we regret the error we made. Indeed, according to Newton and other people, it will work. As a matter of fact, it works better in a vacuum because you're not reacting against the gas around the rocket. The stuff leaving the exhaust is reacting against the rocket.
Yeah, it's
so without the air around it, you've got less drag, and it works better. Yeah. But this is the New York Times castigating a professor, and nastily, what every schoolboy knows, he doesn't know. And that's the kind of thing Goddard got very shy about publishing anything, and also about doing any experiments. He wound up in everybody's favorite place, Roswell, New Mexico, to do his experiments in the late 30s.
Wow.
He developed the first liquid rocket and stuff, and he died in 41. And the government belatedly said, oh, yeah, he did some useful work. They gave $1 million to his wife in about 1960 for using his patents, without permission, so to speak. And they did name the big laboratory the Goddard Space Sciences Laboratory, But what I'm saying is the attitude can have such a nasty effect on the ability to get funding and support and people's willingness to stand up and get involved. That's what bothers me. There's always opposition, but when you make it worse by public castigation, that's terrible. You expect better than that from the venerable New York Times.
Yeah, well, we still have that problem today, except now we call it blogging. However, I have to say that the quality of the blogs is a lot better because, the person that actually runs the blog, who writes the blog, if it's a bunch of nonsense, there's no advertising, so to speak, to keep it afloat. It's only subscriptions. So if no one's willing to subscribe, the blog goes away. So the blog pretty much has to resonate with people who will subscribe to it and spend $1 or $5 or sometimes $60 to sign up for these things. And they get the occasional advertiser, especially if their web visits get high enough where they can get recognized in such a way. But most of the time, it's just fly by the seat of your pants and try to be as organized as you can and vet your material and get it out there and be smart about it. Now, the good news is that the powers that be are losing their exclusivity on the news of the day. You know, in those days, the New York Times was like the Bible. Everybody got it. Lots of people advertised in it. It was a huge enterprise. Today, information moves in split seconds from the time that it hits the internet to the time it reaches the far corners of the world. So ideas can proliferate a lot better. However, that doesn't necessarily loosen up the money, which is what makes a lot of this stuff happen.
Right. And you know, we intentionally included in the book some far out stuff because today's far out today's accepted was yesterday's far out, you know, when you boil it down.
Sure, and, it's just the far out time is coming quicker and quicker.
Yeah, but some of these areas are important. UFOs are one. Kathy has a great chapter on the abduction phenomena with a lot of published references to published scientific data. And there are some people who think, oh, UFOs and abductions, that's all baloney. There is no evidence. The SETI people. So the effort to investigate, I have to get that in. That's what SETI really stands for. Say there is no evidence for UFOs. And, of course, they never reference the large-scale scientific studies. And, you know, don't bother me with the facts. My mind's made up. So the book gave us an opportunity to put a lot of references in, a lot of data in. And if people are going to come at us without having read this stuff, which is usually the case, you know. I mean, when I'm on Larry King, I can count on there being some noisy negativist like Bill Nye, the science guy, purpose to deny, knows nothing about the subject at hand. Oh. And so by having references and chapters dealing with the data, and, you know, some of it, Kathy tells about the smallpox, which was the scourge of mankind.
Oh, my goodness.
Some numbers.
I was going to bring that up. I mean, you talk about car accidents or cancer or whatever. They pale in comparison for how many people almost genocidally wiped out by smallpox.
Yeah.
You know, Kathleen, tell us how early smallpox really made its debut on humanity.
It was in about 10,000 B.C. that it appeared in northeast Africa and then traveled to Syria and Turkey and Iraq. And by 3000 B.C., it was in China and India. And so it just slowly made its way around the world. And when the conquistadors went to the Aztec and Incan empires, the indigenous people had no resistance to the disease. And the conquistadors brought the smallpox virus with them. And they also brought African slaves with them where smallpox was fairly rampant. And it spread through those societies and just laid to waste the inhabitants. Most of them died. And the history of the New World was pretty much shaped by the smallpox virus. It wasn't that the conquistadors had huge armies to conquer and enslave the Aztecs and the Incas. What they had was